Hello, this course provides an introduction to the mathematical software MATLAB. In this course, you will learn how to start MATLAB, how to use the elementary functions in MATLAB, and how to use MATLAB to build functions, also to plot functions. This course includes a number of lectures. So a number of videos will be uploaded to this channel. Before starting the first lecture, please do not forget to subscribe to our channel. So the first lecture is just an introduction to MATLAB. In this lecture, we will see what is MATLAB, how to start MATLAB. We will see the MATLAB environments, the useful functions and operations in MATLAB. Also, we will describe the variables, vectors, and matrices in MATLAB, how to define a variable, how to define a vector, and how to define a matrix in MATLAB. We will also provide some examples and applications. What is MATLAB? MATLAB is widely used in all areas of applied mathematics, also in education, in research, and in the industry. MATLAB stands for Matrix Laboratory. So Math is matrix, lab is laboratory. This software is built up around vectors and matrices. This makes the software particularly useful for linear algebra. Also, it's a great tool for solving algebraic and differential equations. It's also useful for numerical integrations. MATLAB is a powerful graphic tool and can produce 2D and 3D plots. It has also some toolboxes useful for signal processing, for communication, for image processing, for optimization, for neural networks and analysis, in addition to many other toolboxes and applications. To see the MATLAB environment, let's see how to start MATLAB. On your desktop, after the installation of the software, you can choose MATLAB, this icon, MATLAB. Double click on this icon. This screen will open. This is the MATLAB environment. It's composed of menus, of buttons, and a writing area. This is called the command window. In this window, you give the commands to MATLAB. Here, you write your commands. In the command window, you will see a prompt like this. Here, you type your commands immediately after this prompt. Once you have typed the command you wish MATLAB to perform, you can press Enter. And this command will be executed. The commands you type here in the command window are stored by MATLAB and can be viewed in the command history window. To see the command history window, you can click here on Layout, then on Command History, Docked. This is the command history window. If I write, for example, a equal 1, so you can see in the command history, you can see the previous command written. To repeat a command you have already used, you can simply double click on the command in the history window, or you can use the up arrow at the command window prompt to iterate through the commands you have used until you reach the command you desire to repeat. So in the MATLAB environment, we have the command window, the command history window, and the current directory. Here is where you to upload files into MATLAB. The list of vectors, matrices, and variables are stored in the workspace. So here a equal 1. Look, this variable is stored in the workspace. Some useful functions and operations in MATLAB we can use, for example, the plus operator for addition, the negative operator for subtraction, the times operator, the star is used for multiplication. Also, we can use this symbol for division. To find the absolute value of a variable, we can use ABS, absolute value of x. The square root of x is written like this, SQRT of x. The exponential is written as EXP. Ln x, natural logarithm, is written as log of x. Sin x is written as sine of x, like this. So to get 2.71, we write EXP exponential of 1. We get 2.71828, etc. Pi can be written as pi. So MATLAB understands pi as pi. I is the imaginary unit. MATLAB can understand this as I. Here you can use a function called elfun. So if we write help elfun in the command window, we get a number of functions frequently used in MATLAB. If we write help elfun, we get a number of functions used in mathematics, like sine, cosine, tangent, like exponential, logarithmic scale, imaginary part, if we need to find the imaginary part of a complex number. And we have here a number of functions for rounding and remainder. These are mathematical functions. So remember, here you can use the help function to search for any function in MATLAB and see the definition and examples about this function. Now let's see how to generate a variable in MATLAB. So to generate, for example, 3 variables which are scalars, we can write a equal 2, for example, b equal 3, and c equal 4. So here we generate 3 variables. So we write here a equal 2, b equal 3, and c equal 4. Now in the workspace we have 3 variables. We define here 3 variables, a, b, and c. Now we can, for example, say x equal a plus b. So we obtain x equal 5. It's a plus b, 2 plus 3, it's equal to 5. Here a new variable is defined and is added to the workspace. If we say y equal c times b, so we get 12. So note here that without semicolon we can see directly the result here in the command window. Also, the variable y is saved in the workspace. But if we add semicolon, we can see the variable saved in the workspace without getting the value in the command window. So the command window so the MATLAB could be used as a calculator, and it's very easy to calculate on MATLAB. Let's calculate these equations. X equal 2 cosine pi, x equal 2 times cosine pi, we get minus 2 because cosine pi is minus 1. If we say y equal 1 plus 1 over 2 plus 1 over 6 minus exponential, so y equal 1 plus 1 over 2 plus 1 over 6 minus exponential, we get an error because here e is a variable, it's not the exponential function. We have to write here instead of e exponential of 1. So the answer is minus 1.0516. Also exponential I pi. So let's say z equal exponential I times pi. So we get z equal minus 1 plus 0i. So the real value is minus 1. The imaginary part is 0. How to create vectors and matrices in MATLAB? We create a vector in MATLAB by putting the elements within two brackets. So let's say x1 equal, so we use here two brackets. Let's say the vector includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is x1. So x1 is a vector with the following components, with 10 columns. We can also create this vector, for example, by typing x equal or x2 equal 1, 2 points, 10. We get the same answer. So look here in the workspace, x1 and x2 are the same. Let's create another vector, x3 equal 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. So this is a vector with 11 elements. So x3 is 1 times 11, so it's composed of 11 elements. We can also type x3 in another way. x4, let's say, equal 1. So from 1 to 2 with the step of 0.1. So here we can obtain the same vector as x3. This is how to create a vector. We can also write x5, let's say, equal to brackets. Let's say 3, 2, 3. We can add comma, 2, comma, 1, comma, 0, let's say. So this is a vector with 4 elements. So this is a way to write a vector. This is another way, and this is a third method. Now, how to create a matrix? The matrices can be created according to the following example. So let's say A equal a matrix of 3 by 3, 3 rows, 3 rows, 3 columns. A equal 1, 4, 7, 2, 5, 8, 3, 6, 9. Simply we can write A equal double brackets 1, 4, 7, semicolon 2, 5, 8, semicolon 3, 6, 9. So in this way we can obtain the matrix. So the rows are separated with semicolons. This is the first row, this is the second row, this is the third row. Now if you want to use a specific element in a vector or matrix, for example, we need to use the third element in x1. Simply we can say x1 of 3. So x1 of 3, we will obtain 3. It's 3. If we say x1 of 5, we will obtain number 5. If we say x3 of 4, so we will obtain, this is 1, 2, 3, 4. We will obtain 1.3. So x3 of 4, this is 1.3. So this is how to use a specific element in a vector. We can also use specific elements from a matrix. We can say A 3 1. It's big A 3 1. So we will obtain 3. So 3, it's the third row. 1, it's the first column. So we'll obtain number 3. To obtain 9, it's in the third row and the third column. So if we say A 3 3, we will obtain 9. So here x3 of 4, here we extracted the fourth element of the vector. We type the variable and the position within parentheses. And to extract an element from a matrix, the first number here specifies the row of the matrix, and the second number specifies the column of the matrix. Note here that in MATLAB, the first index of a vector or matrix starts at 1, not at 0. We can see here other examples. So this is a matrix, a 3 by 3 matrix composed of 3 vectors. This B is a vector of 3 elements. C is a matrix. Here in C we add or we insert a new row in the matrix A. We insert B in A. D, here we insert a new column in the matrix A. So here we have D equal A, comma, B transpose. This is a transpose. So let's apply this. So A is 1, 4, 7, 2, 5, 8, 3, 6, 9. So remember that to repeat the comment you have already used, you can simply double click on the comment in the history window, like this for example, or use the up arrow as the comment prompt to iterate through the comments, like this. So I use now the up arrow in the keyboard to iterate through the comments we have used until we reach the comment we desire to repeat. For example, if I need to repeat A, this is A. Let's define a new vector B equal, let's say 6, 4, 0. This is B. If we want to add B to A, so B must have 3 elements. D equal A, comma, B. Sorry, we have here to add semicolon. So we added B as a new row. So D becomes 4 times 3, 4 rows, 3 columns. If we want to add a column to A, so add B as a column to A, we write, let's say D2 equal A, comma, B transpose. So here you can see B, which is 640, we add it to A. So here we add a new column to A. We obtain at the matrix D2. D2 is now 3 times 4, is 3 rows, 4 columns. We can create an identity matrix, 4 by 4 identity matrix, 3 by 3 identity matrix, or 5 by 5 identity matrix. Simply we can say E equal I. So I means it's a function which creates an identity matrix. And here inside the parentheses we specify the number of elements. So is it a 3 by 3 or 2 by 2 or 5 by 5 or 10 by 10? We can create a matrix of ones by using the function ones. So we can create a matrix F equal 1s, 2, 3. So here we create a 2 by 3 matrix of 1s. And we can clear the matrices by saying simply clear C, D, and E. So clear is a function in MATLAB that erases the matrices. We can do operations on matrices like transpose. So B equal A transpose. So this comma means a transpose. We can add matrices. We can multiply two matrices by each other. We can multiply two matrices element by element. So we do here element by element multiplication by adding dot times. We can multiply a matrix A by itself by saying A power 2, or we can raise each element of A, of matrix A, to second power by saying A dot power 2. We can calculate the inverse of a matrix by saying x equal inv A. Inv I and V is the function in MATLAB used to calculate the inverse of a matrix. So this is concerning the introduction about MATLAB. Please wait for the second lecture. It's about how to create a function in MATLAB. Thanks for listening, and do not forget to subscribe to our channel